Hello everyone, welcome to my YouTube channel. In this video lecture, we will study something about contouring. What all properties does a contour have, and what are the various choice of contour intervals, and what actually a contour is. So let us begin with this lecture. See, what is a contour? A contour is an imaginary line that is drawn on the ground that joins the point of equal elevation. Suppose I say that this is a contour of 100 meters. That means that every point that lies on this line or on this curve will have an elevation of 100 meters from the mean sea level. Suppose this is the mean sea level, then this particular contour will be joining every point that has 100 meters elevation above the mean sea level or any particular datum. It is not compulsory that you go for mean sea level. It can be any datum. And suppose this is the contour, it is of 150 meters, then this will be joining every point that lies above 150 meters above this datum or above the mean sea level. See, since this point, suppose this is a point that lies on a contour of 150 meters, then this particular point will be above 150 meters from the datum. So suppose I say that any other contour that is of 100 meters or that is of 200 meters. So is it possible that that different contour will also pass through this point? Since this point is 150 meters above, so can this point be 200 meters above? No. One point cannot be at two different heights above the datum. किसी भी तरीके से this is not possible. So every contour has its own uniqueness. No two contours can intersect at any point. Now a term comes that is called as contour interval. What is this term called? Suppose I say this is a contour that is of 100 meters, suppose, above mean sea level. Now suppose I say that this is another contour inside this contour that is of 150 meters. So you can imagine that what it will be representing. It will definitely be representing a hill. Suppose when you view a hill, it will be like a circle and a top point. It will be like something like this. So when you view its elevation, then suppose this is a point that is of 100 meters, this is the contour, then definitely this will be above 100 meters and this will be suppose 150 meters. Then such contours represent hills. When an inside contour is of higher elevation as compared to the outside contour, then it represents a hill. Similarly, suppose if this would have been of 50 meters instead of 150 meters, then it would have represented a lake. When you go inside a lake, the outer portions have higher elevation. When you go inside, the elevation gets lower and lower and lower. So this is representing a hill. I just gave you an idea of what this contour is representing, but I was talking of contour interval. What is contour interval? Contour interval is the distance between these two contours vertically. This contour is representing a distance elevation of 100 meters. So suppose this is a contour that is representing 100 meters. So this contour will be 50 meters above this contour. So this 50 meters is the contour interval. This is the vertical distance. This 100 meters is the vertical reference. This is mean sea level. Then at 100 meters above this mean sea level is the contour of 100 meters. Then above this 50 meters above this 100 meters contour will be the contour of 150 meters. So there is a vertical difference of 50 meters between these contours. So this 50 meters is called as contour interval. How to calculate the contour interval? You just have to subtract this and this. You will get the contour interval. Now there is a term that is called as horizontal equivalent. Now what is horizontal equivalent? So horizontal equivalent is the distance between any two points on the consecutive contour. Suppose this is one contour and this is another contour. Then the horizontal distance between these two contours will be called as horizontal equivalent. You cannot calculate this horizontal equivalent by the contour elevation that it represents. You will need some another data to calculate this horizontal equivalent. It is not very much important. What is important is contour interval. Now let's start with the choice of contour interval. How will you choose that interval of the contour? That means one contour you have taken off 100 meters, another you have taken off 101 meters, another you have taken off 105 meters. So what will be the contour interval? How will you decide that what should be the contour interval? Either you will take 100 meters, next one will be 150, next will be 200. Either this could be the series, or 100, 101, 102, this could be the series. So this depends upon several factors. Let us study them one by one. Let me write the topic: choice of contour interval. CI means the contour interval. So the first thing is nature of ground. Nature of ground depends. Nature of ground means either the ground is very flat or the ground is highly undulating. These two things can be possible. Either the ground can be flat or the ground can be undulating as well. In case of flat ground, you can easily imagine that every point will have very minute difference between their contour points. Suppose this is a contour of 100 meters. Since the ground is flat, this will be a contour of 100.0004 meters. So this is just imaginary. There is very little difference between these two. So since there is very little difference between these two, you will have to go for smaller interval of contour. If you will go for large interval of contour, then there will be errors. The contours should be represented in a proper manner. Suppose you chose one for 100 meters, the next you will have to go for this one. You cannot directly go for 101 meters, since the 101 meter and 100 meter contour will be very far apart in that area. Since this is flat ground, you can imagine that at how much distance you will avail this 101 meter contour from this 100 meter contour. So you have to take smaller contour interval in case of flat ground, but in case of undulated ground you will have to take larger contour interval. Why so? You have to see, this is suppose 100 meter contour. You will very soon approach the 101 meter contour. If you go for 100, 100.004, then these contours will be very close to each other and you will not be able to make them on a map. You will not be able to show them on a map very clearly. So for flat contours, for flat ground you go for smaller contour interval, and for undulated ground you go for larger contour interval. Now moving on to the second factor, it is the purpose of survey. See, if the surveying is done for a very precious job, suppose you are going for railway survey. This is a very important type of survey. For such surveys, you do not compromise with anything. So you take small contour interval. And if the purpose of survey is not very much important, it is a basic residential survey or not that high precision survey, then you go for larger contour interval. So the purpose and extent of survey is also very important. The precision and accuracy that you demand in the survey is very important. The next point is the time and expense of survey. Time and expenses of survey. If you have very large time, you have no time boundation, then you go for smaller contour interval. No time boundation. Since you have time, you can go for small contour interval. First of all, you will go for 500 meters. Then instead of directly going for 550, you can also go for 505, 510, since you have time. But if you do not have much time and you need to do the work very fast, then you will have to choose larger contour intervals. Similarly, the expense, if you have high cost availability, high money availability, capital availability, then you will go for small contour intervals. But if the expenses available are not that much, then you will go for higher contour interval. The next and the most important factor that decides the contour interval is the scale of the map. Just remember for time being that scale is inversely proportional to the contour interval. If you have the large scale, if the scale is large, then the contour interval will be small. Now what does this mean? See, what does large scale mean and what does small scale mean? This is a small scale. This is a large scale. This is a small scale. It is decided by the representative fraction. Now since this is a large scale, it will require smaller contour interval. Why so? You are representing 1 meters just by 100 meters. 100 meters is represented by 1 meter. That means you have very large. Suppose you are preparing a plan of a residential building and you are preparing a map. In a map, since you are locating countries and continents, in this plan you are just locating your residential building. In case you are locating the maps, the scale will be small, since you will have to go for large length to depict the smaller length. You will represent thousands of kilometers by 1 centimeter. But in this case, you can represent thousands of kilometers by 100 centimeter as well, since it is a plan and it does not cover much area. Since this is covering very large area, you will have to go for large contour interval, since this will create a messing up of all the contours. You are covering a very large number of continents, very large area in this particular map by choosing a small scale. Then since you are choosing a small scale, you cannot depict every detail. The details will not be that much clear that you will be able to choose small contour intervals. You will have to go for very high contour intervals. But in case of map, since the area is very limited and you are choosing a large scale, you can go for smaller contour intervals, since you can depict each and every detail very clearly in the case of plan. So this is how scale is dependent on the contour